Okay, this is the Target 2G factoring polynomials and finding real zeros retake video. So it says list all the possible rational zeros of f of x and find all the zeros of f of x and factor f of x into linear and quadratic factors. So to list the possible rational zeros, we look at the constant, factors of the constant divided by factors of the leading coefficient. So we're looking for factors of 15, which are plus or minus 1, plus or minus 3, and plus or minus 5. And those have to be over factors of 3. So plus or minus 1, plus or minus 3. So that gives me, I'm going to do 1 over 1, 3 over 1, 5 over 1. So plus or minus 1 over 1, plus or minus 3 over 1, and plus or minus 5 over 1. Now I also have to check plus or minus 1 over 3, plus or minus 1 over, plus or minus, that would be 3. Let me change the eraser. So it'd be plus or minus 3 over 3, but 3 over 3 is just 1, so we do plus or minus 1 over 3, plus or minus 3 over 3, which is just 1, and we already have that written down, and then finally plus or minus 5 over 3. So these are the possible zeros. Now we have to find the actual zeros. So to find the actual zeros, we're going to do synthetic division. Alright, so I'm going to look, this is x to the third, x to the second, x to the first, and no x. So I don't need any placeholders. So I have 3, negative 11, 1, and then 15. So my goal, since this is a third degree, is to find just one zero. If I find one zero, that'll turn it to a second degree, and I can factor to find the first. So I always start with plus or minus 1, then I would do plus or minus 3. And maybe 5 before I try 1/3 or 5/3. It's just easier to do the math this way. So let's just start with positive 1 and see what happens. So the 3 comes down, then 1 times 3 gives me 3, and negative 11 plus 3 is negative 8. Is that right? 11, 10, 9, 8. Yeah, so negative 8. 1 times negative 8 is negative 8. 1 plus or minus negative 8 is negative 7. This gives me negative 7, and this is 8. So that one didn't work. So let's try negative 1. So 3, negative 11, 1, and 15. So negative 1 times 3 is negative 3. And that gives me negative 11 minus 3. 11, 12, 13, 14, which is negative 14. And negative 1 times negative 14 is positive 14. Ooh, this is looking promising. 1 plus 14 is 15. And then negative 1 times 15 is negative 15. And that does give me 0. Okay, so I know one of my factors. So right now I have f of x equals, since my 0 is negative 1, the factor that goes with negative 1 is x plus 1. And then this started out life as a third degree, but I'm going to use this, and this is going to be x to the second, so 3x to the second minus 14x plus 15. So using these numbers as the coefficients, starting with x squared. So I have x squared, x, and a constant, but the coefficients are 3, and then the negative 14, and then my constant is 15. So now this I can just factor, or try to factor at least, using the normal methods. Alright, so we need to factor x plus 1, 3x squared minus 14x plus 15. So I have x plus 1, and then 3x and x, and then we have 5 and 3. So I'm going to try 5 here and 3 here. and we need the x's, so let's check. That gives me 5x, and that gives me 9x. And when I add those, I get 14x. I need them to be negative, so I need negative here and a negative here. That gives me negative 5x, negative 9x, which is negative 14x. And then negative 5 times negative 3 is positive 15. So right here are my factors. My factors are x plus 1, 3x minus 5, and x minus 3. Now to find the zeros, I let each of these factors equal 0. X plus 1 equals 0, and I get x is negative 1, and of course that was that one right there. And then I let 3x minus 5 equal 0, and I get x is 5/3. And then lastly, x minus 3 equals 0, so x equals 3. So my zeros are negative 1, these are my actual zeros, negative 1, 5/3, and 3. And these were my factors right here. So it asked for the possible rational zeros, that's these. These are my factors, and here are the actual zeros. Okay, let's look at problem number 2. So for problem number 2, we're going to do the same thing. So we're looking at factors of 18. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. All over factors of 2, which are 1 and 2. So when I look at those, I get these 1, 2, 3, 6, 9, and 18 all over 1. So 1, 2, 3, 6, 9, 18. And then I have to look at all of these over 2. So 1 over 2 is a half, plus or minus 2 over 2, which is 1, plus or minus 3 over 2. We did plus or minus 1 over 2, plus or minus 2 over 2. 2 over 2, remember, is just the one that worked, that we already have. And then I have to do 3 over 2. Then 6 over 2, but 6 over 2 is just a plus or minus 3 that I already have. So then plus or minus 9 over 2. And then finally plus or minus 18 over 2, but that just gives me the 9 that I already tried. So these are my zeros. And that gives us a lot to check. But again, I'm going to start small, and hopefully we'll get lucky. Okay, so do I need any placeholders? I have 4, 3, 2, 1, and none. So it looks like negative 2, 1, 16, 3, and negative 18. And then 1, so negative 2. 1 times negative 2 is negative 2. And that's negative 1. 16 minus 1 is 15. And 1 times 15 is 15. 15 plus 3 is 18. And 1 times 18 is 18. And look at that. I got that one works. Okay, but this time I have to actually find 2 using this method because this is an x to the 4, so this just went to an x to the 3rd. So I need to get it to x squared so I can factor it. So once one works, I have to try that one again to make sure that it doesn't happen more than once. So 1 times negative 2 is negative 2, 1, negative 1, and negative 2 is negative 3. And 1 times negative 3 is negative 3. 15 minus 3 is 12. 1 times 12 is 12, which isn't going to give me 0. So I'm going to actually erase this because I'm running out of space. And then instead of trying 1, I'm going to try something other than 1. So I could try negative 1. Let's actually try 2. or negative 2. And I'm going to bring this down. And negative 2 times negative 2 is positive 4. And again, now this time I have to do it to my new answer. This will reduce it down to the second. So I'm using this line here instead of the original line. So negative 2 times negative 2 is 4. Negative 1 plus 4 is 3. Negative 2 times 3 is negative 6. And 15 minus 6 is 9. And negative 2 times 9 is negative 18. So this worked. I knew the answer. I cheated a little bit so that I could, save some time on the video. But on yours, you just have to keep trying. I would have tried negative 1, then probably 2, and then negative 2. So I wouldn't have tried that many before I actually found the rest that will work. So this gives me this polynomial. So I have the x minus 1, which is the factor that goes with plus 1, and x plus 2, which is the factor that goes with negative 2. And then finally, I have negative 2x squared, because of that, plus 3x plus 9. And then if you can factor it this way, that's really good for you. The problem is I cannot. That negative screws me up. So when I factor that out, I get 2x squared minus 3x minus 9. And then I'm just going to bring this negative right out to the front. So I have x minus 1, x plus 2. And then I move that negative, so it's not there anymore, times this. This is easier for me to factor. I just really have trouble factoring when the leading coefficient is negative. So I get this, x minus 1, x plus 2, and then here I need 2x and x. And then 9 probably is going to be 3 and 3. Let's just check. This gives me 3x, and this gives me 6x, so that's looking good. Looks like a negative 3x. I need a negative 3x, so negative 6x and a positive 3. So let's see, I have x minus 1, x plus 2, 2x plus 3, and x minus 3. So the factors are negative x minus 1, x plus 2, 2x plus 3, and x minus 3. And then I need my zeros. So remember, zeros are when I set these equal. So x minus 1 equals 0, so I get x is 1. X plus 2 equals 0. So x is negative 2. And 2x plus 3 equals 0. So I get negative 3 halves. And finally, x minus 3 equals 0, which is 3. So my zeros are 1, negative 2, negative 3 halves, and 3. Okay, and that's it for my practice problems. So now remember, you have to do the following practice problems at home on your own, and bring them either to me or to a math lab teacher to double check, and then you can do the retake. And this is number 1 and number 2. Good luck.